Hi there. In this video, we will go over Amazon Web Service Lambda for the AWS Certified Solutions Architect Associate exam. Let's understand what is AWS Lambda. AWS Lambda is a managed service provided by AWS. So as a customer of Amazon Web Services, you are only responsible for your application code. AWS Lambda manages the compute fleet that offers a balance of memory, CPU, network, and other resources that are needed to run your code. Lambda also performs all the operational and administrative activities on your behalf, which include managing capacity, monitoring, and logging your Lambda functions. The use cases of AWS Lambda are many. For example, from these images which have been pulled directly from AWS documentation, Lambda can be used for file processing. For example, when a photograph is taken, that photo is uploaded to an S3 bucket and that triggers Lambda and it runs some image resizing, and that information is then either stored or displayed to the end client. It can also be used for stream processing, where social media streams are directly inputted into Amazon Kinesis and Lambda gets triggered, and certain information or data is then pulled out from those streams and uploaded onto a DynamoDB database. AWS Lambda use case also extends to web applications and IoT backends. For example, for IoT backends, certain sensor data is uploaded onto Amazon Kinesis, and from Kinesis, Lambda is triggered, and then Lambda runs code that is running in the backend to either place new orders or run any other function which is specified in the AWS Lambda code. Also, it can be used for mobile backends, where you can use it to basically run notifications for user-generated activities. Now let's move forward and understand some important AWS Lambda concepts which are likely to come in the exam. First, let's understand what exactly is a function in AWS Lambda. A function is a program or a script which simply runs in AWS Lambda. Trigger. A trigger comes from a resource or configuration that invokes a Lambda function. For example, triggers are generated by AWS resources such as Amazon Web Services S3, DynamoDB, or API Gateway. Lambda functions then react to these events. An event is simply a JSON formatted document that contains data for a Lambda function to process. Now, how are Lambda functions invoked? When you invoke a function, you can choose to invoke it either synchronously or asynchronously. When there is synchronous invocation, you wait for the function to process the event and then return a response. With asynchronous invocation, what Lambda does is Lambda queues the event for processing but returns a response immediately. Then we need to understand what is concurrency. Concurrency is the number of requests that a function is serving at any given point of time. When a function is invoked, Lambda provisions an instance of it to process the event. While the function code finishes running, it can handle another request. If this function is invoked again while a request is still being processed, another instance is provisioned, increasing the function's concurrency. This feature of concurrency is what makes AWS Lambda scalable from multiple requests. Now let's go some of the advantages that AWS Lambda brings, which could potentially be exam questions. So some of the domain knowledge requirements that you see on the left over here. So domain 1 states you need to design resilient architectures. And in order to design resilient architectures, you need to design a multi-tier architecture solution which comprises determining a scaling strategy for components used in the design and selecting an appropriate compute and storage service based on requirements. So to answer the first requirement, determine a scaling strategy for components used in the design. Now Lambda lets you scale without managing and provisioning servers. Since you pay for what you use, you can automatically scale and descale, and that makes it an appropriate choice for a scaling strategy. Additionally, when selecting an appropriate compute service based on requirements, AWS Lambda manages the compute fleet that offers a balance of memory, CPU, network, and other resources to run your code. In addition, Lambda operates the compute infrastructure on your behalf, allowing it to perform health checks, apply security patches, and do other routine maintenance. Because of these advantages, it makes it a great choice for selecting an appropriate compute service based on the requirements of your application. In addition to designing resilient architectures, you need to design a highly available or fault-tolerant architecture and select highly available configuration to mitigate single points of failure. The key word is making it highly available. Lambda is inherently highly available because it is managed by AWS. the customer does not need to worry about high availability of Lambda. Another requirement is to determine when to leverage serverless technologies to enable decoupling. Decoupling is critical when building modern architectures on the cloud. AWS Lambda is ideal for event-driven architecture that uses events to trigger and communicate between decoupled services, and is common in modern applications built with microservices. By combining Lambda with SQS and SNS, you can enable decoupling. Domain 3 requires you to design secure applications and architectures, and some of the requirements of that is to design secure access to AWS resources and select appropriate services that create traceability for access to AWS resources. Now, AWS Lambda automatically integrates with other AWS services to help you monitor and troubleshoot your Lambda functions. Lambda automatically monitors Lambda functions on your behalf and reports the metric through Amazon CloudWatch. This feature of Lambda ensures that automatically you can create traceability for all the access to the AWS resources via Lambda. Finally, you need to design a cost-optimized architecture, and you need to identify cost-effective compute services and determine options to minimize total cost of ownership through managed services and serverless architectures. Now, Lambda is a great choice because you are simply charged based on the number of requests for your functions and the duration it takes for your code to execute. This is highly appropriate where you need to create a cost-effective architecture. So let's understand what is number of requests. Request is basically Lambda counts a request each time it starts executing in response to an event notification trigger. And this duration is calculated from the time your code begins executing until it returns or otherwise terminates, rounded up to the nearest 1 millisecond. Now let's go over the differences between AWS Lambda and EC2, which are both compute offerings provided by Amazon Web Services. The first difference between EC2 and Lambda is the use case. EC2 is ideal when your workload needs to run regularly and it must run most likely throughout the entire day. However, Lambda is ideally suited for applications where you have unpredictable workloads with very high volume that have sudden short bursts of activity and equally quick scale downs in activity. So when you need to run instances for highly unpredictable workloads which are generated suddenly and need to shut down also suddenly and typically have high volumes whenever they are instantiated, then it would be best to use AWS Lambda. Another area of difference is what type of service is EC2 and Lambda. EC2 is defined as infrastructure as a service and it has to be managed by the customer, whereas Lambda is either a platform or function as a service which is managed fully by AWS. When taking into account security, with EC2 you need to configure all firewalls and security groups for EC2. However, for AWS Lambda, it operates the compute infrastructure on your behalf, allowing it to perform health checks, apply security patches, and do other routine maintenance without your involvement. When looking at scalability, EC2 and Lambda both are scalable. However, with EC2, scalability is achieved when it is configured properly by the customer. With Lambda, Lambda is automatically scalable as Lambda is brought up and spun down automatically depending upon the requirements of the event triggers. When taking into account cost efficiency, EC2 is cost efficient for workloads with long duration that are highly predictable. However, AWS Lambda is not cost efficient for workloads with long duration and highly unpredictable. As mentioned in the use case, it is ideally suited for workloads which are highly unpredictable, which have high volume and sudden spikes of activity, and also need to be scaled down quickly at the same time. Now let's quickly go over the differences between AWS Lambda and Elastic BeanStalk, which are both platform as a service compute offerings by Amazon Web Services. So AWS Lambda is suited when all you need to do is run your API or code in response to events without having to configure backend compute resources. This word backend compute resources is critical in the difference between Lambda and Elastic BeanStalk, because BeanStalk helps you to set up your application that can respond to queries and store persistent information without having to configure all cloud resources that are needed for the application. Let's understand the components of service. So AWS Lambda generates the compute servers that are needed to run your code and connects to other AWS services. Elastic BeanStalk, on the other hand, sets up full stack infrastructure which contains EC2 instances, databases, security and scaling groups, and many more AWS components. In terms of flexibility in configuration, Lambda is fully managed, and thus you cannot select the type of compute resource you require for your code. Whereas with Elastic BeanStalk keeps everything easily accessible, which allows clients to select the servers and the tools quickly. Finally, pricing. AWS Lambda is a chargeable service. Lambda has a free tier which includes 1 million free requests per month and 400,000 GB seconds of compute time per month. Once the free tier is used up, you are charged based on the number of requests for your functions and the duration it takes for your code to execute. However, for Elastic BeanStalk, there's no charge for using Elastic BeanStalk because you pay for the AWS resources that you store and run your code. So this completes our video overview of AWS Lambda. In our next video, we will go over AWS Batch, which is another essential compute product from AWS. So if you like this video, please hit the like button, please subscribe and keep watching our videos. Thank you.